coming all the way from India, and being in Bay Area is kind of overwhelming, but I'll try to do my best and make it worth your while. This is what we're going to talk about today. Space economy, in general, Artemis, what is the Artemis project? It's a very flagship project by NASA, and the aim of Artemis is to get humans to moon, not just to visit, but to stay there. So what it takes to go to the moon. So here is a small comparison I would like to make between space and AI. AI is an enabler. It helps you to process information faster. Space is like terra firma. So you are walking on ground, then you go into water, you swim in water, and then you go in air. You behave differently. But the principles more or less remain the same. Only the amount of information and the time you have to make a decision can vary very significantly. And that's how AI comes into picture. So this is what we're going to talk about, touch base on a couple of these things. Space economy currently is $500 billion today. I think maybe 10 years ago it would not have been even 1/10 of it. But in the next 5 years, another $500 billion is going to be added to this $500 billion. That is what should make every one of you excited. So you can see some stats on how AI in space is growing by 23%. There are companies like Leo Labs. The job of Leo Labs is to tell the satellite launchers what is the possibility of your satellite being hit by this size or maybe by this size of a space debris flying at you at 17,000 kilometers per hour and make it non-usable. That's what Leo Lab does. It's a purely AI company. They make a lot of money out of that. So space debris management, you can see that already there are 130 million pieces of debris floating in the low Earth orbit, which is between 400 to 600 kilometers above Earth's above Earth's surface. So you can sometimes have a call, sometimes somebody can ring a bell in your house, sometimes it can just be wind, but you go out to sea. Only in the case of space, if you have a false call, even to generate a false call, you have installed so much of infrastructure, but if it's a false call, you have to do maneuvers in your satellite, and those maneuvers cost very precious fuel. For example, the Starlink satellite has a fuel for only 350 maneuvers in space. If they get false call, and if that 350 is probably instead of the 5 years of life, if it's run out in 2 years, then the satellite can't save itself. So that's a very critical case of what AI can do when they are cancelling out. And if it's cancelling out the 97% of false call, it's somewhere 95% accuracy and okay. So there's somewhere 97% in third you can see. So very expensive piece of equipment which are worth hundreds of millions of dollars, which can't be repaired as of now. You can repair your cars, you can repair your aeroplanes, but you can't repair the satellites. They are at the mercy of certain decisions made, and how AI can change the nature of those decisions, save hundreds of millions of equipment. That enterprise is going to be hundreds of millions worth, because it's going to save sort of so many companies from getting into losses. Now we can see the number of launches 10 years ago. Today SpaceX is capable of having a Falcon 9X rocket ready in 3 days time. It's like automotive level of production. Few years ago it would have taken a year to make one whole rocket. Now it's being done in matter of days. How it is being done? Thanks to all of you from AI, thanks to 3D printing, because it's like a match made in heaven, where you can print rocket parts, design them, iterate them very, very fast instead of months. We have a slide later which is called from months to minutes. So it's all, yeah. The cost of launch into low Earth orbit 6 years ago was $12,500 per kilogram. So if you're launching a 10 kilogram payload, which is there to study the atmosphere, that cost 5 years ago was $125,000. Now it's reduced to 1/5 of it. Now it's going to be $25,000. So that opens a lot of space for more people to get into space. Okay, so what is Artemis project? Artemis project is basically human settlement on space. How it will be done? It's like if you want to move to a new city, the first time you want to go there, see what's happening, how the city is like, you like the weather or not. So this is what we did in 1970s. Now they did it in Artemis 1 project again in 2020. They circled around it. So Artemis is basically SLS rockets. These are space launch systems, Orion spacecraft, and Gateway Lunar Station. I'll explain all these, to you briefly. So these are the stages of Artemis projects. This is how it's going to be launched. Now, imagine a rocket. So I think all of you would have gone to the Statue of Liberty. A rocket is usually double the size. So imagine that rocket going with 6G speed into the sky, consuming 5,500 kilogram of fuel per second. 5,500 kilogram, that is worth maybe 2 or 3 of SUVs put together. That's how it is consuming per second. In the first 150 seconds, the booster stages, which carry roughly 1.5 million pound weight of fuel, in the first 150 seconds it's gone. So the calculation, the materials, the risk involved needs a lot of computation going inside it. There's a lot of risk involved, a lot of mass involved. Plus now with reusable rockets, before what used to happen, the rockets would just go out in the atmosphere, they will land in the sea, nobody would care, nobody should get hurt, that's all. Now SpaceX is retrieving these rockets, the booster stage is called Super Heavy and Falcon 9. So the booster stage is like a pet puppy. It's just getting back into the booster, they call it chopsticks. They are huge mechanical arms from which the rocket has launched. So 150 feet or maybe 50 meters plus tall structure flying out in the sky with Earth's gravitational pull being directed with fins and thrusters back into the same spot where you launched it from. That's a whole lot of AI. That's a whole lot of calculations. So those guys now need heat shields. What is a heat shield? Heat shield is something which will protect your rocket from being burned, because now we are using reusable rockets. We are having reusable rockets. So we need certain tiles of ceramics which add weight to the rocket. So earlier, whatever weight we reduced by using 3D printing and AI is getting added up again. So now new calculations are coming. And if we lose a single tile, now what happens when the rocket goes up? It's cryogenic fuel inside, minus 100 degrees, all cryogenic fuel. The steel structure is shrinking, and the tiles which are attached to the steel structure are getting compressed, and they have a chance of getting broken because the ceramics is brittle. When it's coming back, it's expanding, and when it's coming back at 1700 degrees C. So if you miss a single tile, the hot plasma will go inside and fry everything, and if there's any fuel left, there's a possibility of an explosion. So yeah, so this is again long, we can go into this longer, but we'll go further than longer at this moment. Okay, so what is the thrust produced? The thrust of each booster is equivalent to Boeing 747 at takeoff. 14 Boeing 747s taking off at one time is the amount of thrust produced by one booster. There are 4 of them. Okay. So there are 3 ways to travel to the moon. One is a direct shot. You have a lot of fuel, you have a very heavy rocket, and now 95% of the rocket weight at the launch is basically fuel. Only 5% is what is there, which is called the rocket. Rest is fuel, and whatever is the payload which has to be delivered is sometime 100, 200, 300, 500 kilograms out of a rocket which is probably weighing 500 tons. So the whole job is to put the satellite in a certain orbit. Okay, so this is Gateway Lunar, which is basically going to be, so there's something called International Space Station, which is circulating around the planet 400 kilometers, 450 kilometers above the sky. Satellites and shuttles can go dock, and this space shuttle has to be continuously manned. It's manual, people have to stay there. The next space shuttle is going to be rotating around the moon, which is called the Lunar Gateway. Because people don't want to come back to Earth to refuel, to pick up supplies, to pick up radiation levels and take everything. So Artemis project is all about working in the cislunar space, which is moon and beyond. And this is also called the gateway to Mars. Now there is something on Mars and Moon. It's called regolith, which is the soil of the planet. So you can see that there are certain payloads: Lister, Luger, Lexi, and Lunar Magnetic Sounder. Magnetic Telluric. Sorry. You can see technology demonstrations. One of that is electrodynamic dust shield, because there's a lot of dust on lunar surface, and when you are launching so many of sensors, cameras, everything, you don't want it to be destroyed. So you want to know what kind of material, and this information you have to send it something to the moon. So you should have some feedback from the previous rovers that okay, we sent this, out of this 5 lenses, maybe this lens gathered more dust, so let's see which material this was. So all these kind of small experiments, they cost millions. And why are we investing in space? Because the next economy, right now we use GPS. So GPS was, it was a work of NASA. NASA needed GPS, that's why we use GPS. So you can see how many apps run on GPS. Your Uber delivery won't come if you don't have GPS. That's how it has reached within our lives. Okay, so yeah, there are 3 ways of traveling to the moon. One is direct transfer method, the other one is ballistic lunar method. You can directly have a very powerful rocket go straight to the moon in 3 days, or you can have something which reaches the Earth escape velocity, then go round and round Earth, then get pulled up by moon's gravitational surface. It's a longer process, requires many more orbital maneuvers, complex, but very economical. This is how Chandrayaan went to moon in 40 days. Wherever the first rocket went in 3 days, that was the 1970s. So this is how